Okay, the calculator paper for 2018. The first thing I will say when I do these, when I start these papers, is just have a look at your formula sheet. Remember, there's a lot of good stuff in here, and also know your calculator as well. Okay, so using your phone might be fine just now, but when you come to the exam, you have to use a calculator. So just get used to using a calculator because there's lots of little tricks and nuances and idiosyncrasies that you need to get used to before before you're comfortable with something. So don't use your phone and then change your mind. On the day and use a calculator. Not change your mind. You'll have to use a calculator in the exam. You can use your phone. So please get used to using your calculator. All right. So question one. Let's get my pen. Households in a city produced 125,000 tonnes of waste in 2017, and the total amount of waste is expected to fall by 2% each year. Calculate the total amount of waste these households are expected to produce in 2020. Okay, so graphically what we're saying is in 2017, the waste is 125,000. Okay. We don't care about 2018, we don't care about 2019, we want to get to 2020. So how many years is that? 1, 2, 3 years. Okay. So what you could do, the long way, okay, is we could times this number by 0.98, all right, and that would work out 2018. Okay, so 0.98 there, that's a 2% reduction. Okay, if we're going to increase a number, it's going to be 1 point something. If we're going to decrease, it's going to be 0 point something. So 1.10, right? That's an increase of 10%. Okay, 0.90, that's a decrease of 10%. Okay, so you're going to mark right away for knowing that 0.98 is your reduction. Okay, so the question might confuse people. It's quite wordy, to be fair. But just knowing that 2% reduction equals 0.98, that's you got a mark. Okay. Now you could just do that calculation over and over again, and you'll get to the right answer. So if I get my calculator here, let's see, 125,000 times 0.98. So that's going to give me 122,500. Okay. Now I could then take that number and times it with 0.98 again. Okay. And that would give me, that's a bit messy now, sorry, 120,050, and then times it by 0.98 again, and that's going to give me 117,649. Okay, so I could do it that way. That's a long way of doing it, and actually it doesn't really require a lot of thought, does it? The only information the only maths knowledge you need is to know that 0.98 is a 2% reduction. Okay, I think anyone could look at that and say, yeah, it's pretty straightforward. What we're really looking for here is a slightly different method, because this, what they said, 20, 50. Okay, we can't do that over and over again. Okay, so what they're really looking for us to say is 125,000 times 0.98 to the power of 3. Okay, and that is going to give us the same answer. Okay, so you've got your initial amount, you've got your percentage change in here, which should have been decimalized, and then you've got the number of years in here. Okay, so that's the answer to that one. That's a method you should be using. Okay, this method is what you might start off with, but this is what we should be using for a kind of compound question. Okay, so you're getting 1 point for your 0.98, you're getting your second mark for this line and your third mark for this line, and the only thing I've forgotten is just to say tons as well. Okay, just always keep your units correct. Okay, so nice easy question to get started. All right, bigger than 1 is getting bigger, less than 1 is going to get smaller. Okay, good stuff. Question 2. The diagram below shows a circle. The radius is 7.4. Calculate the major length of AB. So we're looking for the length all the way around here. Okay, so this is a really common question. Comes up in the non-calculator as well, and it's kind of the only equation they don't really give you actually. We need to know that the circumference of a circle is pi times the diameter. Okay, so say that we're asking for the whole circle here, right? What is the circumference of a circle? that'd be quite easy. Say what's pi times the diameter. Okay, it's going to be pi times the diameter, which would be twice of 7.4. So it's going to be 14.8. Okay, that'll be the entire circle. Right? But we don't want this little segment in here. Okay, so the equation has actually got a times theta over 360 at the end, which then factors the full circumference based on the degrees in the middle. Okay, that'd be times 320 over 360. Okay, and all that's doing is saying what's the full circumference of a circle, and I'm going to ratio it down based on the degrees. Okay, it absolutely makes sense. If we had 90 degrees in here, that would come out as a quarter. Okay, so say our so I'll redraw that. But yeah, just say we're looking for like a big pizza slice. Okay, we know the radiuses are, and we're saying, well, what's the major arc here? Yeah, we know that's a quarter of a pizza. It'd be the exact same expression, but this bit would be 1/4. Okay, it's a quarter of the circumference. So this bit obviously can be any degrees. Okay, so theta over 360. So that's the only equation you're not going to get in this exam. Okay, the only other mistake people can make is to do the diameter is 7.4. That's quite common. So yeah, I'm just going to stick that in my calculator. Okay, so in the calculator, that is coming out as 41.329. So I'll just round it to 33, and it's in centimeters. Okay, so the question's not asked for rounding. So I think 2 decimal places is totally fine. I think the marking instruction seems to just have the two main numbers. But yeah, I think 2 decimal places is good. So just watch see something's asked for that. The other one is that obviously it's the calculator paper, so pi is going to be just pi on your calculator. It's going to be the full number. It's not going to be simplified to just 3.14. Okay. So yeah, again, get used to using your calculator and know where your pi button is. All right. So if we're doing marks for this, you're getting a mark for the 320 over 360. So that's really good. You're then going to get a mark for the full expression. So pi times your radius, so that's getting you a mark, and then filling it all the way through. Completing the expression, the answer, I suppose that's what I'm trying to say. You get a mark for that as well. All right. Okay, I wonder if I can get question 3 in this video as well. Yeah, that should be okay. Magnitude of vectors. Really straightforward. Again, when you see these questions, you should be absolutely loving life. The magnitude questions are brilliant. So the magnitude always makes me think of Pythagoras. Okay, and we should all be familiar with Pythagoras. Okay. So say I've got 2 vectors, right, and I've got call that A and I've got B. Okay. If I add A and B together, it's going to give me this vector here, vector C. Okay. Now to me, that's kind of like the magnitude of A and B. I always think of that. So that was a Pythagoras expression. Okay. So say we had A was 3, B was 4, C would come out as 5. A squared plus B squared square root. Okay. So A squared plus B squared is equal to C squared. So C is equal to A squared plus B squared square root. Okay. So that's what was the magnitude makes you think of. If I've got this vector A and this vector B, what's the magnitude? What's going to be the distance between them, kind of thing? That's what jumps to my mind. Now, just because it's in 3 dimensions doesn't make any difference. Okay, it's still the exact same equation. So what we're going to do is square each of these numbers. So 24 squared plus minus 12 squared plus 8 squared and square root. Okay, so when you think of the magnitude, try and remember that. Try and think, oh yeah, it's basically the same as Pythagoras, isn't it? I'm just looking for this, effectively this length. Okay, so stick that in your calculators. So 24 squared is 576. So 576 plus now 12 squared is going to give you 144. 8 squared is going to give you 64. Okay, so add them all together. That is 784. So still got the root in there. So it's root 784, which is 28. Now you should be feeling good. You might not get a whole number at the end of these. It might give you a surd, but when I get a whole number, it does make me think, yeah, I've probably done that right. Okay. So just hit the marking scheme. Yeah, not a lot you can really do with that. You get a mark for this first line, and then a start for the actual solution as well. Okay, so vectors, dead easy. I suppose the only thing you might have got wrong here was taking this away. So don't forget, a negative number squared, anything squared is going to be a positive number. Okay, yeah, that's about it. Good stuff. I'm just going to pause that.